Hey everybody, my name is Nicholas Wolfram and I co-operate Jim's Automotive Machine Shop Inc. with my dad, Jimmy Wolfram. On the internet, we go by JAMSI online, which is just our initials, and that's the name that you'll see all of our part sales and Instagram and Facebook and all of our socials on. In this video, I'm taking you through a recent rebuild of some cylinder heads that we did for a 7.3 liter Ford Powerstroke. So on these cylinder heads, we did a complete rebuild, complete valve job, and some surfacing, including some upgraded parts like the comp cams, valve springs, and Engine Pro Nitro Black valves. We also installed new nozzle cups for the injectors, all new valve seats, and new valve guides. So the first step in any remanufacturing process when we do this in our shop is obviously the cleaning, but I didn't get any footage of that. Next, we resurfaced the manifold surface and the cylinder head gasket surface. All this surfacing was done on our RMC 1000 boring and milling machine. We also magnaflux all the cylinder heads before we do any machine work on them, just to be sure that we're not, performing unnecessary work on a head that's cracked. In this case, they weren't cracked, and I didn't get any footage of that. So the next step that I'm doing here is drilling out the old valve guides and reaming them for our new valve guides to be driven in, because obviously when we checked the valve guides, they were pretty worn out on these heads. After I've performed that process, I'm going to go ahead and drive in the new valve guides using our air hammer, and basically we just put a little bit of oil on them and drive them in. The replacement guides are a little bit long. There's my dog. So we go in and we'll trim off the top of the valve guides so that they look just like they did, OEM from the factory. So here's a little bit of a clip of that. Basically, it's just this end mill with a pilot that goes down in the guide. In this clip, I'm also reaming the guides just to bring them a little bit closer to our final guide diameter. So finally, I use our diamond valve guide hone to hone the guides to the correct clearance for the valve stem to guide clearance. And basically the hone just gives it a much nicer finish than, say, a reamer would leave. So honing the valve guides is definitely one of my least favorite parts of this process, but it leaves a nice finish, and it is a little bit messy and a little bit time consuming given that you have to use the honing oil, but at the end of the day it's worth it to do the best job that we can possibly do. After all the valve guides are in and honed to size, the next step in the process is to cut our counterbores for our new valve seats. So on a diesel head like this, where the deck of the cylinder head is parallel to the valves, we're able to level the deck surface and basically set a stop on our depth on our machine here so that we can cut to the same depth across the entire head for installing our new seats so that they all come out at the same exact depth. And if you couldn't tell, that tool rides on a pilot that goes down into the valve guide so that our new seat gets driven in concentric to the guide. And anytime that we make a lot of chips like this, we try to use our vacuum cleaner just to clean them up right away so that we're not spraying just an insane amount of chips all across the shop. So here I'm driving in the new valve seats. So the intake seats and the exhaust seats are actually a different material because the exhaust seat needs to be a little bit harder than the intake seats do. Next I moved on to cutting the valve seats, so I got my 3-angle cutting insert. This is for the exhaust valves. It has a 37.5 degree seat angle that is 71 thousandths wide. And there I'm just trying to get you a good image of the 3 angles that are on the cutter. And basically that cutter goes on this fork that then goes onto our tool holder. And And this is a ball drive system that basically rides on a dead pilot that's in the valve guide. And then it has an adapter for our machine that basically can compensate for any discrepancies in the alignment. It does do pretty well, but you still need to be pretty close to level. And here I'm just showing kind of what it looks like when it's up against the seat. It does also ride on a bounce spring, and our table floats on air to get basically centered up on that pilot so that our seat gets cut perfectly concentric and level to the guide. This machine is a little bit outdated. It's what my dad started with back in 1983, but we just purchased a new Surdy 4.5 valve seat machine that is going to be quite a bit better, quite a bit more accurate, and it's going to allow us to do things that our current machine is not capable of. So stay tuned for that in the future. Hopefully I'll be able to post some video of that on this channel when it comes in. So what I've done here is I've started cutting my seat, and I'm actually starting it a little bit small, and then I'm checking it on the valve. Basically I put some magic marker on the valve and I kind of lap it against the valve seat that I've cut, and it'll show you where your seat is contacting the valve face. I'm also checking the depth here just to make sure that we've got enough room to bring our cutter out wider and get that seat to the right diameter that we want it, so that it contacts the valve face the way we want it to, but maintaining our depth limits that we want to have. So what I just did in that clip is basically use the adjustment screw to bring that cutter out just a little bit farther, and here I'm tightening it back down so that we can make another cut and verify that our seat is at the correct diameter. So again, here I'm just double checking that after I brought that cutter back out a little bit, that we're going to be at the right width. And again, I'll double check the depth because we want to cut our seats so that on the exhaust they are between 52 and 64 thousandths of an inch below the deck surface. And we use AERA Process Pro engine specification software to look up specifications for basically every application that we have come through the shop. And again, in this case, on the exhaust seat for the 7.3 Powerstroke, they specify the valve recession to be between 52 and 64 thou below the deck. So as I'm going through and cutting all of the exhaust seats, I'm going to make sure that they fall within that range. The first valve seat always takes the longest because you're making sure that your cutter is set up and you're taking it slow just to make sure that everything's working properly. But once you get the first one cut, you're able to roll through the rest of them pretty quickly because you don't have to do as much adjustment, and you're able to just cut them and verify that they're to the correct depth. So if you look closely here, you see all three of those angles that give you the term a 3-angle valve job. So next I just make sure I'm level. Actually, this is a time lapse of doing all 4 of the exhaust seats on the next cylinder head that I did. Because like I said, the first one was kind of setting up, and the next one I did a full time lapse of all the steps so that we could get a good view for you guys. With our current valve seat machine, I do like to hit them with a grinding stone after I'm done cutting them just to make sure that everything's perfect. But with our Surdy, we should not have to do that. I then go through a pretty similar process for the intake seats, except for the fact that it is a 30-degree seat instead of a 37.5-degree seat. The intake seats are also a different material that's a little bit softer. They're still pretty hard, but they are softer than the exhaust seats because the intake seats do not experience the extreme temperatures that the exhaust gases put on the exhaust seats. Here's a quick clip of what it looks like after I'm done cutting the seats. But what we want to do is kind of match the throat angle to the new seat because they might not match perfectly. So I went in with some of our old Myra tooling and basically used a radius cutter to blend in the new seat to the old casting of the head. So if you pay attention in this next clip, you can kind of see how that blends a lot nicer into the port compared to the previous clip. So after all of our machine work is done, we run them through our jet wash one more time, just so that we can get all of any cuttings or any debris that might be in the cylinder heads. We want to get that cleaned out before we reassemble them. So finally we're ready for the reassembly process. So I started by putting all new freeze plugs in, and after I did the freeze plugs, I moved on to putting the nozzle cups in. Next, I put the valves in and did some measuring so that we could make sure that we had the correct installed height for our new valve springs. And after I verified all of that, I was able to install the valves and the springs, and obviously new valve stem seals as well. So after they're completely reassembled, we do all of our final checks, including vacuum testing the valves just to make sure that they're sealing properly, and then we bag them up and send them out the door. So I hope this gives you kind of some insight into what we would do on a set of Ford 7.3 liter Powerstroke cylinder heads. Thanks again for watching this video, and if you have any questions, just drop a comment below or message me on Instagram. I'm going to put a link in the description because we do sell some of these parts on our eBay store and on our website. So if you want to purchase any of the parts that were used in these cylinder heads, you can go there to check it out, or you can send us a message. And again, thanks for watching. If you have any questions, just let me know, and stay tuned for some future videos. Like I said, we have a new valve seat machine that's coming in, and hopefully that's going to be able to let us do some really cool things and really step up our game, and keep bringing the quality work for our customers that my dad has brought since 1983. So thanks for watching. Again, I'm Nicholas with JAMSI Online, and have a great day.